I'm not going to ask you to be quiet. You are going to need a calculator, okay? So maybe go get one. Perfect. Okay. So the first thing that we're going to talk about is scatter plots. So those three images up there are scatter plots. Does anyone know what a scatter plot actually is? Like if I had to define it. There's no set what? Yeah, I'm going to throw some words out there that maybe you don't know. So a scatter plot is created when you have bivariate data. It's represented with points, and it is not necessarily linear. It can be, but it doesn't have to be. So bivariate, bi means two, variate sounds like variable, right? So it just means that you have two variables. You're representing data from two variables. For example, if I had you guys come in here and write down how tall you were compared to your shoe size, we could compare your height to the size shoe you wore. They don't necessarily have anything to do with it, but they could, right? There could be a correlation. Does that make sense? So it's just two types of data that you're collecting that don't have to be related to each other. Okay, so I want you to look at the pictures that you have there and use your idea of slope. And let's talk about that first box. It's increasing. Oh my goodness. It's increasing. And we know that when things are increasing, that means they have positive slope. Okay. Do you see how this set of data points is so like close together that I could maybe almost draw a line right through it? Do you guys see that? So this is increasing. It has positive slope. It's linear. And we actually call that positive slope. We call it positive correlation. Meaning if I kept it as shoe size and height, your height and your shoe size have a positive correlation. Your height helps determine the size of your shoe, okay? Let's look at the next one, and I'm going to change the color on that, and I'll write maybe nothing. Okay, so let's look at this one. So I'm going to put all the things that we can say about this green one up above it. Negative slope. What else? We could almost draw a line through that. I totally agree. So this is linear. What kind of correlation do you think it has? Yeah, negative correlation. Is it increasing or decreasing? It's decreasing. Okay. Now let's look at the very last one. What are some things that you can tell me about this one? It's definitely nonlinear. What'd you say about increasing? Yeah, it's really hard to tell if it's increasing or decreasing. This has really no pattern. It's not trending upwards. It's not trending downwards. It has no pattern. So it has no correlation. So do you see how slope lends itself to really identifying correlations? Correlation, even though they're not the same, they are not the same, but they kind of look the same. Correlation refers to a scatter plot, slope refers to a line. So do you see how they kind of look the same? Okay. So I want you to look at this first example and tell me if there's positive correlation, negative correlation, or no correlation. So let's look right here first at the graph. What do you think?
Positive.
Yeah, positive. This has positive correlation. What about the table? How would we even go about figuring out if that table had positive correlation?
I feel like the top is negative because it goes down.
So the top is going down by 1. You're exactly right. Do you remember how we talked about the change in y over the change in x? Yeah, that's our slope, right? So we know that x is going down. What's happening to the y? It's going up, right? Is it going up by 3 every time?
No.
No, it's not. But it still is going up. So that means it's got a positive, like, growth. What happens when you take a positive divided by a negative? Okay, so it's negative correlation unless, here's when it wouldn't be negative correlation. If as x gets smaller, so as these x values are decreasing, these y values are getting bigger. It wouldn't be negative correlation if all of a sudden these numbers started getting really low. Like say I threw a 56 in there, or maybe a 42, because then that would give me that kind of popcorn effect. Okay. All right, so now we're going to try and do some matching. Yeah. And do you? Okay,
A little bit.
good.
Like I don't remember how to do it, but I remember seeing it.
It's pretty easy, and we're going to use Desmos. Okay. You good? Okay, here we go. Shh. So let's match the scatter plot, the graph, to these example choices, A, B, C, and D, or A, B, and C. So A says the number of trucks on the road and the number of days in the month. Let's just go to the next one. B says the time you spend driving and the distance traveled. Which one do you think would represent the time you spend driving and the distance you travel? Graph 1, yeah. The time you spend driving and the distance. Notice how the longer you drive, the more distance you cover. So this goes with graph 1. I agree. Okay. What about the number of months that you own a car and the value of a car? So this is the age, number of months. And this is the value of your car. What happens to the value of your car? Is it going to stay brand new forever? No. Yeah, it depreciates. It gets less and less. So this is graph 2. My uncle was a car dealer, and he always used to say that the minute you drive a car off of a lot, it's lost $10,000 in value. I think it's pretty close to being true. Like, especially if you buy a $60,000 or $70,000 car. Yeah. Isn't that crazy? Yeah, I guess. Okay, this last one. So number of trucks on the road. Do the number of trucks on the road and the number of days in a month have anything to do with, like, no, they don't. So this would be letter A or graph number 3. No correlation at all. They, like, one does not affect the other, just doesn't affect. No correlation. Okay. Are you good? That's fine. We're good. We can wait. Okay, thank you, ma'am. All right. So correlation coefficient just goes in between -1 and +1. So here's what I want you to think about. I'm going to kind of draw a graph that represents a very strong positive correlation. So if I have a very strong positive correlation, maybe like a correlation coefficient of 0.85, it's going to look something like that. That's positive. If I have a very strong negative correlation, it's going to be something like this. This could maybe have a correlation coefficient of -8, -0.8. I want to show you what a correlation coefficient of +1 looks like, and a correlation coefficient of -1. What can I do with those dots? You guys see them even? Probably not. What could I do with those dots? Yeah, I could draw a straight line through them, and it would have a slope of 1. What could I do with these dots? Draw a straight line through them, and it would have a slope of -1. So real strong positive correlation is in between like 0.8 to the whole number 1. And real strong negative correlation goes from -1 to like a -0.8. Anything in this is going to kind of give you that snowstorm effect. Okay. All right. So, sorry. So we're going to talk about regression, and we're going to do a whole lesson on regression, not today. But the stronger that your R is, whether it's positive or negative, it doesn't matter. The stronger that your R is, your correlation coefficient, the better that you predict your data. And here's what I mean by that. Do you see that this example right here has a correlation coefficient of -1? Let's suppose that the line had the graph had like the equation -1/4 x plus 7. That means if I wanted to find out what happened when x was 10, pretty sure using this equation, I'd pick a point, like I'd get an output that was right on my line. That's what that means. Whereas if your correlation is not as strong, like a point -9, like that -0.9, that means if I used this model and let x equal 10, I probably wouldn't get an output of a point that was right on the line. It might be right off the line, still pretty close. So we're going to use that correlation coefficient tells us how good our predictions are going to be. But we're still going to use the lines of best fit, the equations, to make predictions. Just the stronger the correlation is, your correlation coefficient, the better your predictions. So do you think that you would have a better chance of making a prediction with an equation from this graph or from this graph? From the first one, because first of all, it has a stronger correlation coefficient. It's 0.6, even though it's negative, where this one is 0, no correlation at all. And secondly, you can see that they've drawn a line through there. Those are called trend lines. Okay. So these are just examples of what good, strong correlation looks like compared to like what it doesn't look like. So that's just a picture. Just go keep on going. Okay, so we have 4 graphs and we have 4 correlations down here. Do you guys see that? 4 R's, correlation coefficients. So we're going to match the graph above with the R correlation coefficients down below. So remember I said if all of the points fall on the line, Antoine, say again. Yeah, please. Yeah, R equals +1, because if all of the points fall on the line, your correlation coefficient is going to be either +1 or -1. Okay, so R equals a -1. So we've used these two. How are you determining that it's -0.7? Good job, because it's a negative slope. Yeah. And this is kind of like what you guys are going to see at the end of the year when you take your EOC. These questions came right off of the EOC from like 3 years ago. Okay, so does this make sense? Remember, if the points are all on the line, it has a correlation coefficient of 1. It's either just going to be positive or negative depending on the slope of your line, the slant. Okay, so lines of best fit, trend line. So we call them lines of best fit. And this, so they are just equations that model the data. Okay. They're always written in slope intercept form. The better R value that you have, meaning like R equals 0.9 or R equals 1, the better your equation is at predicting values. So scatter plots are used a ton in business. So think about like marketing or sales. What's your guys' favorite restaurant? Olive Garden. Okay, let's talk about Olive Garden. They have a lot of commercials. I've never seen a Floyd's commercial, so you guys, we should make one. Yeah, I'm sure. Not a commercial, a nightmare. Sorry. Anyway, so let's talk about Olive Garden. Because I know that you work all the time. It's probably a nightmare. Okay. No, I was talking about his job at Floyd's. Listen, listen. So Olive Garden. So right now they're running this big promo. If you go in there and eat, you can take like 5 different meals home for $6.99. Have you guys seen that on TV? Okay. So I don't know. I think it's like eat here, take home later, or something like that. Isn't that what it's called? Yeah, a smaller portion. So I think there are 5 or 6 choices that you could take home. So anyway, let's say that they collect data and the number of people that come in and the amount of money they spend. The more money they spend, they realize that they sell more of these little meals, right? So what they're going to do is maybe they're going to run a campaign and say, hey, I want to figure out what the correlation is here. Because maybe I'm thinking about talking to the owners and seeing if they can invest $200,000 into marketing. And because if it continues, if this trend line continues, then our sales should triple. So scatter plots are used to make projections about future sales, whether they're positive or negative. That's when so businesses use scatter plots. They're also used in growth model and in insurance costs and things like that, which are no fun, but definitely in marketing. So let's look at this. So we are not going to do the calculator part today. We are going to do the calculator part tomorrow. So I linked to your module today the Desmos calculator. So I want you guys to kind of pair up because I don't want everyone with their MacBook open, but I linked the Desmos graphing calculator. And if you don't want to go to the Desmos graphing calculator, listen, I'm still talking. You can, if you don't go to the link, you can just type in Desmos. Are we listening? You can just type in Desmos graphing, but it's linked in your module.
Just because Olive Garden is good, but it's back year you come to Olive.
No, he hasn't. Yeah, I know. I think Floyd's is amazing. I go there every chance I can. Shh. Okay, listen up. Shh. Listen. So how many of you guys, you guys need to go to Desmos Graphing. I'm not like talking like I'm being ridiculous. Like get there. Got to do it. Okay. Yeah. Okay. So we are going to do example number 3 together. We're going to do example number 3 together. So I wrote directions on this side of your notes. So like if you open your notes up like a book, the directions here tell you what we're doing here, but I'm going to kind of walk you through it. Okay. So we've all gone to, at least every partner has Desmos opened up, right? So it says click on the plus button. So here I am. Do you see that? I'm clicking on the plus button, and it says a table option will appear. You guys see the table? Okay, so click that. Now, it has been my experience that the easiest way to build data is to do all of your X's first, to go down the whole list, and then go back and do all of your Y's, okay? So we are just gonna start typing in all of the X values that come from this oil changes per year. Does that make sense? So I'm gonna call them out as I type them in. 3, 5, are you guys with me? Okay, I'll wait for you. Are we ready to keep going? Okay, so you should have 3, 5. Your next X value is 2, 3, 1, 4, 6, 4, 3, 2, 0, 10, and 7. If you missed one, that's what your partner's there for, to help you catch up. Now we're gonna go to the Y values. It's on your paper. I'm not just like making this up. It's right on your paper. Yeah, I said we're gonna do example 3 together. Shh, listen up. Okay, so I'm gonna put in the Y values. Maybe just watch this first one. 300, 300, 500, 400, 700, 400, 100, 250, 450, 650.
600.
Thank you.
0.
Thank you.
10.
Thank you, ma'am. Okay. So once you input your data, if you go to your directions, it says Desmos will graph your data points. And if you look, I'm going to kind of shrink up my graph. You see that my data points are all here. There is. It is. There is a magnifying glass right here. It'll take you right to all your points. Okay. Good call on that, Kate. Thank you. Okay. So we want to know what the equation is for this line. We want to know what the equation is, meaning what line best represents that data. Do you think it's going to have positive slope or negative slope? It's going to have negative slope. So the way that you're going to figure out what that line is, it's going to give you the equation. You don't have to do any math. It's going to do all of it for you. You're going to use the little squiggles. So here's what I want you to do. Type in Y and then the number 1. It'll automatically drop your 1 as a subscript. Yeah. The squiggly is up here by your, like right above your tab button. So you want to hit shift and the key that's right above your tab button. And it gives you that, it looks like the Spanish tilde, right? Yeah, you shift from last year. Yeah. So you guys are going to use the same thing again, right? MX1, and then we're going to do plus B. So that's what you're typing in. And it is going to give you your equation. Did you get it? No. So Y and then just the number 1. Just I said Y and then the number 1, and it's automatically going to drop it for you. Okay. Are we good?
Yes.
Okay. So let's talk about what's in here. First of all, what is the value of R? Our correlation coefficient. R, just R. Yeah, so our correlation, listen, is negative 0.914. So do you think that the equation that we get is going to be pretty good at making predictions? Yeah, it is. Okay. Does it tell you in your table here what your M and your B is? It does. What is your M? Negative 73 point what? Negative 73.07. And what is your B? It was like 650, I thought. What is your B? 650 point, I'm going to say 0.27. Is that okay? M is your slope. It's negative 73.07. I know that looks horrible. M equals negative 73.07. B is 650.27. Okay, your R is negative 0.914. Negative 0.914. Okay, so we are going to write an equation with this information. So how would I go about writing an equation in slope intercept form with this information? Yes. Huh? Put it back because I didn't have any whiteout. I had to go back to the office. Like I didn't have any whiteout when I came back on Monday. Shh, that's fine. You're fine. So what's the equation going to be? Y equals plus 650.27. This is our equation that represents the data we have plotted off to the right. So it says, is the data linear? Is your data linear? Yes. It has negative correlation. Are we listening? Okay. The second question says, find the slope of the line. Well, that's what our M is. M equals negative 73.07. Describe in words what this slope represents. Well, we're talking about the price of repairs depending on the number of what? What are we getting every year? So basically, the repair cost decreases by how much? $73.07 with every oil change. Meaning, the more you get your oil changed, the less amount of money that you spend on repairs. And I would say that that's probably very true. Okay. So the repair cost decreases by $73.07 with every oil change. That's what our slope represents. So now let's talk about the y-intercept. So the y-intercept, B, is $650. We're just going to round it to 650. What does that represent? Well, let's see. The y-intercept happens when x is what? Listen to me. The y-intercept happens when x equals what? 0. So if I'm crossing the y-axis at $650, that means I had how many oil changes? 0. 0 oil changes. And remember, that's your beginning, that's like the beginning value, right? That's like the most you're going to pay. If you don't have any oil changes, you're going to pay $650. It asks you for the x-intercept. Do you guys remember when the x-intercept, like what the value of, what happens to the y when you cross the x-axis? Y equals 0. So where in this table does y equal 0? At 10. So this means that you have 10 oil changes. That's your X and Y intercepts. Okay. Question D says, hey, let's make some predictions. Let's make some predictions. So it says use the equation, and that's our equation, y equals negative 73.07x plus 650.27. Use this equation to figure out your repair costs if you have 4 oil changes. Well, what is that saying? That's saying let x what? Yeah, let x equal 4. How do I figure that out? Yeah, someone calculate that. Someone figure out what y equals when we multiply negative 73.07 times 4 and add it to 650.27. Someone calculate that in their handheld calculator. 357.99. Okay, so watch this. I'm going to go to my Desmos graphing and I'm going to touch the point right there. When x is 4, I'm right at x equals 4 on the line. What's the ordered pair that pops up? 400. And what was our answer again? How close were we to that? Pretty close, not exact, but why are we not exact? Because this is just a prediction, but is it pretty close? Okay. Are we good with that one? Okay, I'm going to stop the video and we're going to do, huh? Yeah, I can. I'm going to stop the video and we're going to do the next couple questions together. Okay.